Hi friends, hope you are doing fine. I am Dr. Ganguly. So today I am going to make a video in response to a query by a reader or a viewer, and essentially this query was about how collaboration can help research, typically for a PhD student and also in some cases for a postdoc or for some faculty person. So now when we talk of collaboration, why is it useful? One of the advantages is that you are able to actually do much more research than you could do on your own. So this is essentially a philosophy of a team versus working solo. So if you work solo, there's a lot of things you can do, but if you get together with somebody else who brings complementary skills, your productivity is going to go up. So that's the basis of collaboration. Now, where can you think about collaboration? I would say that wherever there are two different skill sets which come together. So let's look at some of these possible skill sets. So number one is modeling and experiment, and this is the skill set combination with which we are very familiar. If you study any physics chemistry book, you will see that there are people who did modeling and then there are people who did experiments. For example, there were all these people who were modeling things such as the speed of light and so on and figuring out what it could be, and there were actually people who were figuring out how can you experimentally measure the speed of lights. Similarly, there were people who were postulating various laws such as Newton's laws and so on, and there were people who were actually going around and proving these laws. So much of the work in physics and also in chemistry is some aspect of modeling and then some experiment, and essentially experiments are required to test the veracity of the model or the truthfulness of the model. So generally a model is okay, but people accept the model when it's proved with experimental data. So here, in any situation, if you are a modeling person, you can collaborate with an experimentalist. If you are an experimentalist, you can collaborate with a modeling person, and this is going to improve your research because it's very rare that people have expertise in both these areas. Now the next issue is computers and experiment. So what has happened over the last several years is that modeling has become largely computer driven, and essentially nowadays when we talk of modeling, we are not talking about just setting up differential equations or matrix equations and solving these equations, which was the case in the years gone by and which you often study in the physics, mechanics, chemistry books and so on. So today a lot of computational science is involved, and the computational science can be quite complicated. You can do, for example, molecular dynamics simulation and so on, and so there are some possibilities of verifying these results with experiments. So in those cases, experiments become very important. For example, you may be working in areas such as physics, and there may be some computer simulations which are performed, and then some experiments need to be conducted, say in particle physics and so on, and these things need to be proved. So again, the second skill set is computer and experiment. The third possibility is between data collection and statistics. So with the advent of more and more data, and this has happened because there are large amount of sensors, there is a possibility of storing measurements, there is a possibility of processing these measurements using data manipulation and data science techniques. So a lot of data is there, and you could extract information from this data by using statistical theories. So again, this is a disparate skill set. There are some people who are expert in getting the data, there are some people who are experts in statistics and machine learning, in data science. So this is one more possibility of collaboration. Then the next issue is that of math and computation. So how does math and computation come in? Well, there are many problems where you can do a lot of math, and what I mean by this is you can set up the mathematical model and then you can solve this mathematical model by using purely mathematical techniques, but beyond a point you will reach a situation where you can no longer make progress using mathematical techniques, and this becomes true when you deal with real world systems. For example, if you have a uniform system, uniform structure, you can postulate that the coefficients of your differential equation are constant, then you can solve many mathematical problems which you find in textbooks. But in real life, when you are dealing with the actual system, for example, you are dealing with an aircraft wing, then that thing will not hold. You can no longer apply those simple problems and solve them mathematically in an exact solution manner. So here what you need to do is you need to do computational solutions of these problems. So again, the problem of postulating a mathematical model and the problem of solving this mathematical model are two disparate problems. Here you may need a lot of knowledge of numerical analysis, of scientific computing, and so on. Finally, there is an issue of experiments and machine learning. So you can perform a large number of experiments, and nowadays there is a tendency to actually be able to perform various experiments and also obtain data in operational settings. And you can use this data to set up machine learning models. So in place of setting up physics based models, which was the technique in, for example, physics books and so on, you can actually set up data based models. So essentially here you train some kind of neural network or machine learning system, and this learns the input output relation from the data. So just like Newton came up with F is m into a to monitor or to prescribe the motion of things, you can also come up with something like that, but totally from data science perspective. So this is a field of research which is going on, especially when the physics of the problem itself is very complicated. You really do not understand all the mechanics behind the system and so on. So now let's come to the real world. In the real world, if you are a PhD student, the first collaboration which you start with is with your PhD supervisor. And this is essentially a collaboration because the PhD supervisor is somebody who has done a PhD, who knows the art and science of doing research, and now is working with a junior person fresh out of master's degree program or bachelor's degree program and training them for research. So essentially in this collaboration, in some cases the PhD supervisor will give you a broad problem, and then you focus, drill down into that problem and figure out what exactly your problem is. So that's the first collaboration. Now there are some opportunities of increasing collaboration beyond this point, and one of the simplest techniques you can do is to have a co-PhD supervisor. And if you have a co-PhD supervisor, this person can be from the same department, he or she can be from a different department, and even in some cases this person can be from a different university or a research lab if your university or institute permits this. So the advantage of this co-supervisor is he may bring a set of skills which is very different from what your supervisor has, and this set of skills could actually improve your research. So for example, if you are somebody who is working with a guide who is very good in numerical modeling, then you may want to have a co-supervisor who actually does a lot of experiments, and together with these two supervisors you can write papers which have a higher value and which have a greater likelihood of getting published, and which can be published in impact factor journals or high impact factor journals in Scopus and Web of Science. So that's the first thing you can do. Now in some cases your university may have MOUs with foreign universities, and you may be able to get a co-supervisor from a foreign country. So this would increase the advantage of getting new concepts from a foreign country, as well as permitting you to travel to that country back and forth and work with different professors, expand your network and so on. These kind of collaborations also result in better research, because what happens is there is a kind of cross-pollination of various concepts, and the research work comes out to be better. Now there is also the possibility of working with some other students in the department, and this is a little touchy issue because those students need to be somebody whose supervisors are fine with this particular situation. So you need to keep this in mind. This is more possible if you are, for example, a PhD student and you are working with a master's degree or a bachelor's degree student in the same department and you have a supervisor. But be careful that whatever research you do, it should not go into two theses, because your thesis is supposed to be a body of work which is done by you. So in case it is come out of some collaborative work, you need to mention that in some places that it's come out of collaboration, and the concept should be mostly borrowed from one person, but the one person who is doing the work is the one who gets most of the credit for solving this problem. So there are some touchy issues regarding collaboration among students in the department, so you need to keep that in mind depending on your department's policy in terms of granting degree. Now one more possibility, like I suggested, is working with different professors, but you don't have to do this formally, and I actually like this approach of doing things informally, because then you do not get in trouble with various bodies in the administration and so on. So you can actually collaborate with the person in a different university. Maybe you read his paper and you found some concepts which you can use in your research. So you can write to this person and say, hey, I want to work with some of your problems and extend it further, and very likely they will say yes to that, and you can write joint papers with this person, and this can go into your thesis also. So this case we have done, and it's very easy to collaborate by using situations such as Skype, or you can use Team or any of these Zoom type of features, and you can talk to this person, you can exchange LaTeX files, you can exchange MATLAB programs and so on, and you can do collaboration like this. And for this you really don't need permission of any university or any body, and your papers come out from 2 different countries or 2 different universities, they are likely to gather higher level of citation, they are likely to show that you are a globally active researcher. So these are some issues to keep in mind. Now the question is, how does it help to do collaborative research? Like I mentioned, it does improve the quality of your research. You get concepts from somewhere else. You are also able to improve your productivity. For example, if you were the person doing the modeling, the computation, the experiment, it may take you 2 years to do a amount of work which leads to a paper, but if you are working with 2-3 different people, it may reduce this time to 6 months. So essentially you are much more productive when you work with people like that. This is the basic theory behind specialization. So we want to specialize in one narrow area and then collaborate with people so that the quality of our research becomes better. So this was my take on collaborating, and again remember that collaborating will help you expand your referee network. You will know more people, and you can ask these people later for letters of recommendation and so on. So I hope you benefit from this video. Stay tuned to my channel, and I will see you again sometime soon. See you then.